All right. Today we're going to be talking about squares and square roots. If you are not on page 4 of your notes, please go ahead and turn to page 4 and make sure you have something to write with. What we're going to be doing today is we're going to be describing the relationship between square roots and perfect squares. So today will be a good portion of notes, and the next class will take what we learned this class and apply it and do more activities with perfect squares and in square roots. So the first vocab word is base. And in an exponential expression, it is the number that is being multiplied by itself. So in the example that you have, there's a 5 and a 4. That 5 is the base. That's telling us that that's the number that we're going to multiply by itself. The smaller number, which is that 4, is our exponent. So our exponent is the small number that tells us how many times to multiply the base by itself. All right, and then the next, we can combine the base and exponent together, and we call that a power. And a power is numbers expressed using exponents made up of a base and an exponent. All right, our focus over the next 2 class periods are going to be perfect square and square root. So a perfect square, think of the shape of a square. And we know that the shape of a square, all sides are equal. All sides are equal length. When we think of that, a perfect square is a number that can be expressed as the product of 2 equal integers. So if you look at the image that is on your paper or on the screen, okay, we have a square that consists of 4 purple dots, which means each side of that square has 2 purple dots. So 2 squared is the same thing as 2 times 2, which would equal 4, because there are 4 purple dots in there, or in that square. Now, perfect square, the exact opposite of the perfect square is a square root. And the square root is the inverse operation of squaring. It asks the question, what number, when multiplied by itself, gives us the result? So looking at that example, that's the square root of 16. So we can ask ourselves what number times itself would give us 14. So we can also look at that perfect square. That perfect square has 16 pink circles. And we can look at each side of that square. And each side of that square has 4. So the square root of 16 is 4. All right, now we're actually going to take those definitions and apply them with some practice, okay? The first in the expression 5 to the third power, okay? That 5 is the base, which means 3 has to be the exponent. And this can be read multiple different ways. We can read it as 5 to the third power. We can also read it as 5 to the power of 3. And then some of you guys might also know that the exponent of 3, we can say cubed. So we could actually say 5 cubed as well. So in the table to your right, you will notice that we have exponential form, expanded form, and standard form. Exponential form is being written with an exponent. Expanded form, I like to think of a slinky. If you ever played with a slinky, and the slinky is very compact when you get it, but when you pull it apart, it expands, right? So expanded form takes the exponential form and stretches it out. And then the standard form is the actual answer. Okay, so if we look at that first one, 2 times 2 times 2, we know that 2 is the base, and we're multiplying that 2 3 times. So that means our exponent would be 3. And we would read that as 2 to the third power, or 2 to the power of 3. Then the most common mistake students make is they look at the exponent and the base and multiply them. So 2 times 3 equals 6. No. Instead, you want to multiply the base the same number of times as the exponent. So in this case, 3. So 2 times 2 is 4, times 2 is 8. So our standard form here would be 8. Let's jump down to the third row where we have 49. And what we need to ask ourselves when we're given this standard form, but we don't have the other two, is what number times itself would give us 49? And in that case, hopefully you guys would come up with 7. So 7 times 7 is 49. Now, do you guys notice I did not use a multiplication symbol? I used a dot. Now that we're more into algebra, okay, a lot of times we'll drop that multiplication times symbol and use a multiplication dot instead. So 7 times 7 is the expanded form. And then in exponential form, 7 would be the base, 2 would be the exponent. We could say that as 7 to the second power, or 7 to the power of 2, or we can actually say it as 7 squared as well. Do me a favor, pause this video. You try the last two, okay? Write that in expanded form and then in standard form as well. All right. Hopefully you had a chance to pause the video and try those two. And double check your answers above. Okay. Just be careful. Remember, 4 to the third power is not 4 times 3, but it's 4 times 4 times 4, which would give you 64. Now, there are a couple of special cases when we deal with exponents. And the first is any number to the power of 1 always equals itself. Okay, so the example here is 8 to the power of 1. The answer would be 8. 16 to the power of 1 would be 16. Now the other is any number to the power of 0 always equals 1. So 7 to the 0 power, 1. 70 to the 0 power, 1. Okay, so those are the two exceptions when working with exponents. Now that we understand exponents a little bit, so go ahead and flip over to page 5. We're going to talk about perfect squares and square roots really quickly, and then we'll be done with our notes today. We will do this exploration when I return, so we will skip this today. All right, on page 5, you should see perfect squares. Okay, so remember a perfect square, okay, we talked about is when a number can be expressed as the product of two equal integers. So looking at 25, 25 is a perfect square because 5 times 5 gives us 25. So 25 is a perfect square. The next one, 36, is a perfect square because 6 times what? 6 gives us 36. And then 49 is also a perfect square because 7 times 7 would give us 49. All right, we're going to circle the numbers that are perfect squares, and then I will have you pause the video to do the bottom portion. So it says circle the numbers that are perfect squares. Now remember, when we're looking for a perfect square, we're thinking to ourselves, what number times itself would give us that number? So looking at 3, is there a number that I could multiply by itself to get 3? And no, there isn't. So that is not a perfect square. Now 25. 5 times 5 would give us 25. So yes, that is a perfect square. How about 27? Is there a number times itself that would give us 27? Nope. 100. Is there a number times itself that would give us 100? Yes. Hopefully you thought 10. 10 times 10 would give us 100. So 100 is a perfect square. And then the last one, 49. What number times itself would give us 49? Is there a number? Hopefully you said 7, because 7 times 7 would give us 49 as well. All right, let's do these first two together, and then I'll have you guys pause the video and complete the other 5 on your own. So 8 squared, that means 8 times 8. And 8 times 8 is 64. 7 squared, that would mean 7 times 7, which would be 49. All right. Before you pause the video, I did want to say that unfortunately, this part of the Unit 3, you will not be able to have access to calculators on the SOL test. So please do not use a calculator to solve these. All right, pause the video and go ahead and complete the other 5. Then unpause it to check your answers, please. All right. Hopefully you had a chance to finish those questions, and hopefully those answers look good to you all. Okay. So that is perfect square. The last part of our notes for today is square roots. Now remember, square root is the exact opposite. It's the inverse of a perfect square. So if you're looking at your notes, 9, 16, 25, 100, those are all examples of perfect squares. So what we're asking ourselves is what number times itself would give us that perfect square? So looking at that first one, what's the square root of 9? Well, it's 3. And the reason why is because 3 times 3 equals 9. What's the square root of 16? 4. Because 4 times 4 would give us 16. What's the square root of 25? So what number times itself would give us 25? Hopefully you thought of 5, because 5 times 5 is 25. All right. 100, the square root of 100. What number times itself would give us 100? Well, that's 10. So 10 times 10 would give us 100. So that means the square root of 10 is 100. Do me a favor, okay? Pause this video, okay? Complete the table. And then once you are finished completing that table, it's talking about perfect squares on the left side, the left 2 columns, and square roots on the right 2 columns. So do try your best. See if you can kind of come up with what's going to go in that blank. And then once you're finished, unpause the video to check your answers. All right. For those numbers that are bigger than maybe 12 times 12 or 144, you will probably have to do some trial and error and just say, all right, well, I know that 15 times 15 is 225. Okay, so I know that it needs to be bigger than that. Okay, because like I said, you will unfortunately not be able to use a calculator on this portion of the unit. So hopefully that makes a little bit of sense. We will work more next class on perfect squares and square roots. Go ahead, stop this video and continue working in the slides for the remainder of class. And I will see you guys on, we have off Monday, so Tuesday's an A day. I will see you guys on Wednesday. All right, see you soon.